Okay, for video number 3, so we have the load pattern, define load pattern. So basically, ito lang yan, define, tapos load pattern. I mean, diaphragm muna pala, diaphragm. Okay, so we have here diaphragm, so nandun pa rin, define diaphragm. Okay, so define diaphragm. So we have here, modify natin to rigid. So okay na yan. So that is also the default. So yun yung diaphragm D1. Okay. Rigid. Click OK. Click OK. Next we have here, nakalagay dito is semi-rigid. Okay. Wala naman siyang issue if rigid or semi-rigid. So that's have a wala siyang issue sa transfer ng loadings from slab to the beams and to the columns. Then pag nag-rigid ka, makikita mo kasi dyan yung center of mass and center of rigidity. But if you use semi-rigid, so hindi mo siya makikita. Okay. So sa forces naman is wala naman siyang issue. Wala siya halos ng malaking difference sa transfer of earthquake forces. Okay, so yun yung sa program lang. Now, we have to go to load pattern. So ito, define load pattern. Okay, so punta tayo dito sa load pattern. So, click ko lang to. Yan, click ko na yan. Then we have here load pattern. So, we have to rename this one. The dead will become, let it as D. Then click this modify. Kasi nag-rename lang ako. Okay. Then, this live. So, we can rename this, or we can have to make it as super dead, or that is for the SDL, or we can have that name as SD. Then kasi itong live na tong nasa baba na to, papalitan natin ito, i-rename natin, kaya nakaklik ako dito, tapos pinalitan ko to ng SD. Then ito, papalitan ko tong super dead instead of live. So yung live hindi na yan, so super dead. So super dead load, or that is superimposed dead load. And I will click modify para ma-rename siya and para ma-update yung super dead from live load dati. Okay? I will just click modify. Okay na. Then, I will just put here. So, nakadalawa na tayo. Dead and is dead. The dead is super dead. The dead is self-weight, Then, the SD is superimposed dead load, or that is super dead. That is the one that derived from the thickness of topping, ceiling, partition. Okay. Then we have to add RLL. That is reducible life. So just click this one, drop down, then add. Now we can add. Next, live. We can put L. Then type niya is live. So the reducible live, that is the live load less than 4.8 kPa. Okay, so ang office natin, office live load, that is 2.4 kPa. Okay, 2.4 from that table of the live load from the code. Then, yan yung reducible live. Then we have live. This is for the, add naman natin, this live is for 4.8, equal to 4.8 live or above. So when you have stair, that is 4.8 ang live load niya pagka office. Pero pag bahay, the stair sa bahay is same as in the residential occupancy, which is equivalent to 1.9 kPa. So pag mga bahay lang, 1.9 lahat ng live load mo. But now we are dealing with the office, so we have live load 4.8 here. So this is live and this is non-reducible live. So you cannot reduce this live. Okay, so na-add na natin. Then we have here earthquake static. So I will just input here EX stat, or that is EX static. Then the type is seismic. Then auto lateral load. So we have lateral load because this is a seismic. Then you can go to UBC 97, then add new load. And then you have here again EY seismic, and then same siya, add new load. Then you have WX for wind, WX auto lateral load ASCE dash 7-10, add new load. And WY same, and LR, that is roof live, or basically pwede natin hindi na i-include yan na roof live. It will pwede naman siyang same as a reducible live, but we will include that for the sake na kompleto yung load cases natin based on the code, because in the code you have 3 different live loads: reducible, non-reducible, which is live, and the roof live. Okay, so we'll include that one. Then type is roof live, this one, roof live. Then you have to add. So makapansin mo dito, yung dead load lang ang may self weight multiplier, and the rest are in 0. Then click OK, but just to save the load cases, load pattern lang. So we will modify the earthquake static load pattern based from this ayan. So I will go back to the load pattern, and I will just click the EX static. Then you have to modify lateral load. Modify lateral load. I will choose EX. So EX plus 5%. This is the 5%. Okay, or we can omit this 5% because we are, pagdating sa load combinations is makakaroon tayo ng orthogonal effect, 100% in X and 100% in Y, or for this tutorial, we can use also this 5% to shift the earthquake forces 5% perpendicular to that width of your building. So it will give you a higher forces, much higher forces based on if you're using only X direction alone. Okay, so we'll use that. Then we have here 0.03. So you have to read that excerpt from the code there in the manual. Then you have here roof deck, base natin is ground floor. Then this is the ductility factor, and this is SD. Then this is 0.4. Then this one is type A, and you have here 6.1. Okay, so this is our along X direction. Now we'll go to along Y direction. Ang magbabago lang is itong direction and eccentricity. So along Y naman, basically ito yung okay, then importance factor 1. Click OK. Then sa wind X tayo. Wind X na tayo. So modify ulit. Modify lateral load. Wind X. Wind X. So sorry, we have here this one will not seismic. So this is a wind dapat. So we can click and WX or wind X, and palitan natin to ng wind, then modify load, then wind naman to, modify. Okay, so now we have here a wind, this one. Okay, then we'll just wind and so okay, wind, but the autolateral load is, so I will just modify again because nawalan ako dito ng autolateral load. Okay, so kailangan dyan is ASCE 7-10. So I will just click WX and select this one, then modify. Also, I will go back here and ASCE 7, modify. So now I have here wind and type na is wind and the autolateral load is ASCE 7-10. Then I will just modify that one. Then we have here 260 kph equivalent to miles per hour. So 162. Okay, so have here 162. Then this is type C. And so we have here a default values. Then this from ground up to roof stair. So include parapet, that is 1.5. Then dito we have here 0 angle. So itong diaphragm natin, wala pa itong mga values kasi wala pa tayong model. Okay. Then create case 1 lang. Okay, case 1. Then 0. So that is for WX or wind X. Click OK. Then you have to go to wind Y, modify lateral load. You have here 162. So dito mayroong value kasi may model yan. May model na. We can go back to this one. Okay. So sa wind mo, balikan natin 162. 162. Then C. Then ito is from ground. Then 1.5 yung parapet wall mo. Then this basically we can use it as 90 para sa along Y direction. Then click OK. Then click OK. So we'll go back to that load pattern of X to have this data pag meron na tayong model. Okay. So ngayon, punta tayo sa load case, define load cases. So your load pattern is equivalent to load case lang. So but in our first step, nagkaroon tayo dito, we rename this one as dead and we rename this one as D and this one as SD. So we'll just rename it again here in the load cases. So modify ko yan, same dapat ito nito. So okay, so we'll just, that is just a text, click OK. Then this one modify SD, so I have here SD, click OK. And the rest are have the same names. Yan, LL. Okay. Okay, so same lang ito lahat. Okay. Okay, can click OK. So that's the load cases. Then we will go to our mass source. Define mass source. This one. Then modify ko yan. I will just click this mass source. SDID 1 and live is 1. So ang kasali lang sa mass source yung 4.8 and above. So itong mass na to, that is the mass of the building, will dictate the forces of the building, also this one. But the reducible live is not included. Okay, the included in mass source is the self weight of the building and the superimposed dead loads and the live load above 4.8 kPa. Then click OK. So the mass source are done. Then Control S ko lang yan. Then you have your Pdelta option. You can have here this value. Define Pdelta iterative based on load. So this is, then we have here sdead na 1.2. Then we have here sdead na 1.2. Then we have live na 1. Then we have here reducible live na 0.5. Then just click OK. Then modal case natin, we have here 12 and 16 and rates vector. So define modal case, modify, then palitan natin ito ng rates, and this one is ux uy acceleration. This is in z direction. Acceleration, this y, then z direction. Then minimum number of modes natin, we can use 12 and maximum is 16. Click OK. Then that is for the modal case. Then we can now define load combination. So define load combination, we have here in Excel, okay, so sa Excel natin, we have Excel, analysis Excel, we have your load combination yung sinend ko. So you have load combinations here. Basically, I will just define load combination. So wala ka pang load combination. Then ito, U1, U2, U3, U4. So basically, I will just input U1 here, add new combo. So susundan nyo lang to, U1. Then we have here dead na 1.4. Add ka ulit, is dead ka ng 1.4. Yan, click OK. So ganun lang. Then you have U2, let's say add copy ko yan. I will just put U2. Then papalitan ko to ng 1.2. Then mag-add ako ng live, reducible live na 1.6. Add live 1.6. Add ako ng roof live na 0.5. Okay, yan yung U2 ko. So ganun lang. Kung gusto mo mag-delete, you have to delete that. Pwede yan, ito. But now you have to, then I will input this one, yung may orthogonal. Let's say we have U5, add new combo. U5. So itong load combinations na to, nandun ito nasa ATABS model itong sinend ko sa inyo. So we will not input this one by one now, as of now. So I will just input this one and you can input it by your own. Okay, 0.5, 1.454. So because we have a CA of 0.509 dito, then ito is 0.5 CA dito. Okay. So yung 0.509 na yan, galing yan dun sa earthquake parameters. So you have here 1.454. SDED mo na 1.454. Then reducible live mo is 0.5. Then live load is 1. Then earthquake mo EX is 1, then EY is 0.3. Okay, so yan na yun. So itong scale factor na to is ito. Yan. Then sa taas titingnan mo. Okay, so in the rest will okay, so ganun lang gumawa ng load combo. Then you have here seismic drift. Okay, so basically load combination. Saan ko po? So yun lang yung load combination. So I will just open the model na meron ng bago tayo pumunta sa modeling, I will just open the model. So ito yung modeling na to draw beams na to, draw column. So bubuksan natin dito yung ETABS model na meron ng kompletong load combination. But basically the load combinations, ganun lang siya i-input. Okay, so pabalikan ko pag may question kayo. Yung 0.5 sa AID, saan ba nanggaling yun? Itong CA na to, saan ba nanggaling to? So basically, dun lang yan galing sa combination of loads. So meron kasi tayong special load combinations na tinatawag. Special load combinations natin due to earthquake vertical. So yung EV, yun yung 0.5 CAID. Kaya yung 1.2 dead mo dito, meron siyang 1.2 dead load alone. And then, yung 0.5 CAID, ito yun. So yun, yung sa to account vertical acceleration. Okay? Then yung CA, yun yung nandun sa ito yan, CA. Yung CA naman na yan, dun yung galing sa seismic parameters natin. Okay, you have seismic parameters, earthquake load. So, basta ito lang, kailangan mo lang tong basahin ito. Ito yung CA natin. Then galing yan. Okay. So basically kasi meron ka ditong distance from the fault. Then you have here type A, source type A. So ito yan. Zone 4 ka, ito ka. So high seismic zone ito. So kalahati dito, ito yung mataas ang seismic. Then ito yung mga fault line natin. Then you have this SD soil type. Then meron ka kasing 6.1, ito 5 and 10, interpolate yan, nandito yon yung value dyan ng NA. Ayan, ang lumabas na NA mo dyan 1.156. ito interpolate yan kasi 6.1 kasi yung ano mo distance mo, NA and NV. Basically yung NA and NV galing yan dito sa chart na to. Itong chart na to galing yan dito. So very easy lang kasi naka-chart naman siya. But your CA and CV is dependent on NA and NV. So yung CA and CV mo naman, ito yung value niyan. Saan ang CA and CV? Okay, ito yung CA and CV mo naman. Ito naman yon. Yon. So meron ka ditong SD 0.4 NA ka daw, and ang CA mo daw is 0.4 NA daw, nasa zone 4 ka. Ang CV mo naman, ito naman 0.64 NB. Kaya you got 0.508 dito, and you have 0.64 NB doon. So, kaya meron ka dito 0.5086. Okay? So, we will proceed to modeling in part 4. Modeling na tayo sa part 4. Okay? Then, I will stop this video.